Hello dear students, our today's topic is the antiarrhythmic drugs belonging to the class 1B, 1C, class 2 and class 3 agents. So let's start with the drug belonging to class 1B. From here we have the first example which is called as Lidocaine, which is also very well known as xylocaine, and this drug is available as its hydrochloride salt form. This is the structure for lidocaine. We all very well aware about this compound being a local anesthetic agent having its effect primarily on the sodium channels. If we look at the structure carefully, we will find the basic nucleus present over here is a two carbon chain along with this nitrogen. So it is called as acetamide. It is the amide group, and though it is a two carbon chain, so it is called as acetamide. For acetamide, this is carbon number 1 and this is carbon number 2. So on 2 we have a diethyl amino group, and on this nitrogen we have this 2,6 dimethyl phenyl group as a substituent. So the systematic IUPAC name is 2 diethyl amino and 2,6 dimethyl phenyl acetamide. Now dear students, this compound is derivative of gramine. Please keep this point in mind. Many times in examination you might have a question on this, that lidocaine is derivative of dash. So you have to identify that it is the derivative of gramine. Now this drug is used intravenously for treatment of arrhythmia that is associated with the myocardial infarction and the cardiac surgery. This drug found to depress the diastolic depolarization and automaticity in the Purkinje fiber. This drug is found to depress the sodium entry during the diastolic process. And one important point is that the important metabolite of lidocaine is monoethylglycine xylenide. That means during metabolism, one of the ethyl group will be removed out from here in the process of dealkylation. More especially here it is deethylation. So dear students, that is the important facts about the drug lidocaine. The next drug is Tokenite, which is available as its hydrochloride salt form. Here you can easily distinguish the structure with the lidocaine. If we insert a methyl group at this alpha carbon in lidocaine, so it will give us the formation of tokenite. Once again, it's an amide, and here the basic moiety will be a 3 carbon chain with a nitrogen. So it is an amide having the name propanamide because there is a 3 carbon chain, 1, 2 and 3 along with this nitrogen, so it is propanamide. It is called as amide because here is CO group attached with a NH, so it is amide. For IUPAC nomenclature, we will select this long carbon chain. So this will be position number 1, this is 2 and this will be 3. So on 2 we have a amino group, so it is 2 amino. On nitrogen we have 2,6 dimethyl phenyl followed by the name propanamide. Now dear students, if you look at the structure carefully, you will find this carbon being a chiral carbon because it is attached with 4 different groups, 1, 2, 3 and 4th one is with hydrogen. So it is a chiral carbon, that's why tokenide exists in its 2 isomeric forms, that is the R and the S. And it is the R isomer, that is the rectus isomer of tokenite, which is about 4 times as potent as the S isomer. This compound has a very good oral activity because this compound is resistant for the hydrolysis, because when this methyl group is introduced at this alpha carbon, this methyl group produces the steric hindrance over this carbonyl group, and due to the steric hindrance by this methyl group, this carbonyl carbon is less prone to get attacked by the water molecule. That's why it is said that this is the alpha methyl group which contribute to the oral activity. This drug is approved for life-threatening ventricular arrhythmia. The next drug is maxiletine hydrochloride. Now dear students, if you compare maxiletine with tokenite, we find a major difference over here. The difference is that instead of NH we have a oxygen over here, and instead of the carbonyl group of tokenite we have a CH2 group here. So with introduction of this oxygen, this compound or this portion will become the ether portion. And once again there is presence of this chiral carbon, that's why the compound is available in the isomeric form. The maxiletine hydrochloride is available as a racemic mixture, and its IUPAC name is RS1 2,6-dimethyl phenoxypropane 2-amine. Now for IUPAC nomenclature we will select this long carbon chain 1, 2 and 3, so it is propane. On second position we have a amine, so it is called as propane 2-amine. As I mentioned that this is an ether and it has the similar effect as that of lidocaine and tokenite. This drug is used for treatment of ventricular arrhythmia. With the introduction of this ether, this compound has a very profound oral activity, as this compound does not prone to get attacked by the water molecule and it resists the hydrolysis. This drug is effective on the Purkinje fiber in the heart, and its primary metabolite is para-hydroxy maxiletine, which does not have the antiarrhythmic property. During metabolism, this phenyl ring undergoes hydroxylation at this particular position, which is para to this oxygen. The oxygen is the orthopara director. So due to this, the hydroxyl group is introduced at this para position to give the primary metabolite para-hydroxy maxiletine. Now the next drug is a very important one. It's called as phenytoin sodium. We are very well aware with this particular drug as an anti-seizure drug, that is also called as the anti-epileptic drug. The phenytoin sodium consists of this Phenytoin ring, which is nothing but the imidazolidine 2,4 dione. That's why in the nomenclature it is simply called as 5,5-diphenyl hydantoin or 5,5-diphenyl imidazolidine 2,4 dione. For nomenclature, the numbering starts with this nitrogen as number 1, 2, 3, 4, and this will be number 5. Now this drug is used in treatment of atrial and ventricular arrhythmias, which results from the digitalis toxicity. If you look at this structure, we find that this hydrogen may migrate over this electronegative oxygen, due to which a double bond can be generated between the nitrogen and the carbon, while this oxo group is then converted into the hydroxy group, that is the OH group, and due to the hydroxy group, the phenytoin tautomer may have the acidic property. That's why phenytoin is very weak acidic in nature. That means it can give or liberate the proton. So So though it is acidic in nature, its salt is made by treatment with sodium hydroxide to give phenytoin sodium. Now dear students, one more ester of this phenytoin is available, which is called as phosphenytoin, which is made by reaction of phenytoin with phosphoric acid. And this phosphenytoin has very good water solubility, and that's why it has the advantage also. The salt, that is phenytoin sodium, is made available in the parenteral form by combining phenytoin sodium with 40% propylene glycol and 10% alcohol. This drug is limited for the parenteral administration through the IV route only. Only the intravenous route of administration is preferred for phenytoin sodium, because it is observed that the intramuscular injection causes the tissue necrosis, which is its lethal side effect. That's why phenytoin sodium is administered only through the intravenous route. The next drug is sotalol, which is a beta blocker and a class 2 agent. This is the classical structure of sotalol. The functional group of highest priority is this one, methane sulfonamide. So that's why in nomenclature we will include this name suffix, the methane sulfonamide. On this nitrogen, so on nitrogen we have this substituent group. So on nitrogen at position number 4, then on first carbon we have a hydroxy group, and on second carbon we have this propane 2-il amino group. This propyl chain is attached with its second carbon with this amino group, so it is called as propane 2-il amino, followed by this 2 carbon chain ethyl, then is phenyl, and followed by the name of the basic moiety, methane sulfonamide. Now as I mentioned that this drug is a non-selective beta blocker. One very important point is that this drug is initially thought to belong to the class 2 agent, but due to its effect on some other ion channels, it is also considered as class 3 agent. That means this drug is included in both class 2 and class 3 due to the similarity of its cardiac effect to both the classes. This drug is used orally to suppress the ventricular arrhythmia. The next drug is Lidocaine, which is a class 1C agent. If we look at the name Lidocaine, we can easily gauge the presence of this chlorine from this lore. This lore is taken from chlor, and this nide is taken from the amide nucleus, and the basic amide nucleus is phenyl acetamide. On nitrogen we have this 4-chlorophenyl group, and again on this nitrogen we have this 1 isopropyl piperidine 4-il group. This heterocyclic nucleus is a piperidine nucleus. For this piperidine, the numbering starts with this nitrogen 1, 2, 3, and this will be number 4. That's why the IUPAC name of Lidocaine is this one. This agent is a class 1C agent. This has some special features, like this compound is found to possess irreversible binding on the fast sodium influx channels. Irreversible binding means this compound will bind with the sodium channels for very long period of time and remain there, as intact and thus is depress the sodium movement across the sodium channels, and its dissociation from the sodium channel is very slow. And sodium channels are though the sodium channels are blocked for longer period of time, we have a prolonged duration of action for this drug Lidocaine. This drug is found to be well absorbed when taken orally, and it has the good safety profile as a good drug efficiency. This drug is used in treatment of ventricular arrhythmia. Dear students, the last drug is Amyoderon, which is considered as class 3 agent. If we look at the name and the structure, we will find the presence of the amino group, and this aron stands for presence of this benzofuran. The iode here stands for the presence of these iodine groups over here. And this drug is approved for treatment of life-threatening ventricular arrhythmias. As I mentioned, this compound basically classified as a class 3 agent, but this drug also have its effect on the ion channels like sodium, potassium and calcium. That's why it is also considered as the class 1, class 2 and class 4 agent. This drug is found to block the lipid membranes where it alters the permeability of the ion channels and the receptors. And though the permeability of the ion channels is diminished, though the entry of all the channels will be restricted, and thus this compound have the antiarrhythmic property. Despite of these facts, this drug is of last choice because of its severe toxicity profile. So dear students, that is all about the antiarrhythmic agents belonging to 1B, 1C, class 2 and class 3 agents. Thanks for watching this video. Please like, share and subscribe. Thank you.